The spiral method is a little bit different because what happens in the spiral method is we start kind of in the requirement specification and we move ourselves into the design. And once we do the design, we will actually implement and test. And we will continue doing these things in smaller iterations, basically to ensure that what we're building kind of builds on everything else. That's kind of the function of the spiral method. So some of the traditional application development characteristics were we coded in a third generation language like COBOL, C. Later on we'll include Java in that. Some of you may have heard of Pascal. And we used a very structured development methodology. Sometimes we talked about automated project management systems. That's generally not the case back in the 80s and 90s. Nowadays you see them a little bit more. Most of the systems had some form of database management system. On the old mainframe systems, that might be DB2. Now you might hear Oracle, MySQL, or even SQL Server. In smaller implementations, it might have been DBase and FoxPro, and now it might be Microsoft Access or even MySQL for that matter. You had a mix of online and batch applications, and what those are is you connect to the server to get some information right away, and if it's batch, basically what the server does is the server just collects all the data, waits until, say, 2 o'clock in the morning, processes everything, because it doesn't need the result until the next day. And the reason that occurred was for optimization. Back in the 80s, everything was mostly mainframe applications or mini computer applications. You did have the notion of client-server, but it was a little bit different. It wasn't as prolific as it would be then in the 90s and nowhere near as what we got with web-based systems, obviously, in the 2000s. Programming was done by professional programmers. You really didn't have a lot of people who just dabbled in it and like users and just come up with something, although you did find some instances of that. I know cases in, say, the police department where some individuals knew a little bit of programming. They would collect data and then they would write these small applications that would help them with crime data for a particular precinct. So it does occur, but traditionally it was, programmers. You went to school for this, you were classically trained and you programmed it. That's the way it worked. And again, you have automated integrated software tools that might help, some integrated development environments, things like you may have heard of Eclipse or the .NET Framework environment, Visual Studio. You have a well-defined sign-off process for system delivery. This is one that carries over because you do see in cases when we implement a system, we want the business users to sign off on it to say, yes, I agree with what was put together, and this is exactly what I want. And finally, user participation mainly in requirements definition and installation phases. This basically would be the bookends. That's kind of changed as well. We look for the users to be involved in almost every part because the iteration cycles are much smaller. We don't necessarily want them in development, but in some cases we do want them as part of the development because we want to test certain modules out on the fly. And you'll see there are programming methodologies that actually account for that. In the structured development, these methodologies basically for the system development lifecycle, they try to manage the complexities of overall systems development. You have to manage a lot of the individuals and a lot of the, honestly, it's really managing a lot of the personalities and egos and who does what. And hopefully your structured development process will help that. In some cases, it reinforced stereotypes, like the senior developer was the guy who or the gal who knew everything that was supposed to know about systems and you just listened to them. It doesn't really work that way anymore. There has to be much more of a collaboration between the two parties. It was more discipline. You had established standards for process. Because there was less people, it was easier to control, but it was very hierarchical. You had higher reliability and fewer errors. Now, I actually would put this off to the side because even now in open source, there is research out there that shows that open source has fewer errors than actual traditional applications. So I'm not sure exactly how this lines up with that research, but it's something to note that it's not necessarily a silver bullet that because you use structured development you're going to get high reliability and fewer errors. You will get in many cases high reliability and fewer errors, but that's not always the case. And more efficient use of resources through project management. I think this is more of a function of project management as opposed to a structured development, but because structured development by definition is structure and project management provides that structure, it's obvious as to why that's the case. So with this we do get cost savings, increased productivity. Well, we will allocate better our human resources and reduce the tendency for system development project overruns. Now that last one is a little bit interesting because while that may be true in some cases, there are a lot of factors that go into project cost overruns, and many of which have nothing to do with the actual structured development. It may have to do with poor requirements, it may have to do with invalid testing, it may have to do with changing requirements. Things like scope creep may increase our cost overruns. So we still have problems with this. In the 80s, we find the advent of these 4GLs and prototyping, four generation languages. They basically are more programming environments. They help you drag and drop components to basically create a screen, and you can add simple functionality. In some cases, they add additional constructs that will allow you to do more with, say, buttons or radio buttons or list boxes and so forth, as an example. And we also see that they allow users to develop programs. So now users are getting directly involved in the development, and we could create these prototypes. And these prototypes would allow us to literally put this application in production, test it out, and see how it works with real life data and real life workflow, so that we can then move forward and say, do we want to continue this or not? So these are some features and functions of fourth generation languages. I'm not going to go through these. You can take a look at this list yourself. But these are important parts of the fourth generation languages. And as I mentioned before, prototyping is really a live working system. It performs the actual work. It may become the actual production system. Usually there's added code or added functionality that's required. But for the most part, we've designed maybe 50 or 60% of the system. And we're just tweaking it a little bit. The purpose was to test the user requirements and overall design, or the workflow and program logic. By doing the prototypes, we could see if our assumptions were correct, that the way we think we do business flow is the way it's actually done. It allowed us to create software quickly, and the language ultimately creates code. It will actually create the code that we will use. So you have one language creating code in another language, say in C. Now, in computer science, that's not a really foreign concept, because if you program in a programming language like C or Java, it'll actually convert that code into a second generation language, which is like an assembler code, and then second generation language has to get converted into a first generation language, which is machine code, because the machine only understands ones and zeros, and those are specific to the actual computer chips that are there. So it's not a foreign concept that one language will create another language. In fact, when you create a new programming language, you actually will create a small subset of this new programming language using something else. So I might create Java with a little bit of C, and then use that thing that I created in Java to build the rest of the language. It's a very fascinating point in computer science and programming language design.